to start 1.3, section 1.3 on absolute value equations and inequalities. These are the learning objectives we're going to cover today. And of course, we're going to start with plenty of examples. So if we look at this equation here, we notice that it has an absolute value function or operation here. And so remember, an absolute value function means that whatever the value of x is, it's going to make sure that it's positive. So the definition of an absolute value function says that if it's the absolute value of x, whatever's inside the absolute value is going to be positive if the quantity is positive, and if the quantity turns out to be negative, it's going to take the opposite value of that. Okay, so again, remember the absolute value of x says that when x is positive, we're just going to keep x positive. When x is negative, the absolute value of x is then going to be the opposite value of that, which is again going to be positive. So it is actually a piecewise function if you think about it. But what we're going to do is we're going to take this absolute value, and so what we know is whatever the value of x minus 7 is, whatever it's inside the absolute value sign, has to be positive. So we're going to use that to help us solve this, okay? And we'll show you here in a second. So we're going to isolate the absolute value sign on one side of the equation. So that's the first thing we need to do. Okay, so we're going to isolate the absolute value. So we're going to put the absolute value on one side, and everything else is going to go on the other side. So again, if we solve this by subtracting 2 from both sides, we get negative 15 over here. And if we divide both sides by negative 5, we get 3. And so we get the absolute value of x minus 7 is equal to 3. Now here's where we need to split this up, because remember, there's two values in here that we could have. Okay, we could have the absolute value. So what this says is that x minus 7 either is going to equal 3, or the opposite value of x minus 7 is going to be equal to 3, because this inside could be either positive or negative. So we're going to end up splitting this into two parts. We're going to say that x minus 7 is equal to 3, or the opposite of x minus 7 is equal to 3. Okay, and then another way of looking at that is we could say x minus 7 is equal to 3, or x minus 7 is equal to negative 3, which is another alternative way of thinking about it. And so it says we're going to consider x minus 7 as a variable, and we'll call it capital X, right? And then we're going to use the property of the absolute values for that. So we're going to say that x minus 7 is equal to negative 3, or x minus 7 has to equal positive 3. And so when we solve, we get x is equal to 4, or x is equal to 7. Now substituting in for the original equation, we get the solution set of either 4 and 7 as solutions. And so what we're using is the property of the absolute value. Okay, so what we're saying is that if x represents an algebraic expression and k is a positive real number, then the absolute value of x equals k implies that either x equals negative k or x equals positive k. Okay, because remember, either x is positive or x is negative. Okay, if x is positive, then x equals k. If x is negative, then we're going to say the opposite value of x equals k. But in this case, we're just solving for x. Okay, I hope that makes sense. So let's look at this one. So we're going to do the same thing. We're going to isolate the absolute value on one side and the rest on the other. So we're going to add 9 to both sides. And so we'll get 17. So then we're going to get the absolute value of this is equal to 17, which is going to tell us that either 5 minus 2/3 x is equal to 17, or the opposite of this is equal to 17, which means we can divide both sides by -1, and that gets us what we had down here. So if we look at that, that's what we have. So we have, if we drop the absolute value signs, in order to drop the absolute value, we have to say that this is equal to 17 or it's equal to -17. And so we get these two equations. Okay, and so if we solve each of these independently, then what do we get? Well, we get x equal to 33 or x equal to -18. Okay, and again, all we're doing is solving these two equations. So here we're going to subtract 5 from both sides, and if we do that, we get -22, and then we divide both sides by -2/3, and we get a positive 33. And then over here, if we do the same thing, we get -18. And of course, we got to make sure we check. So if x is equal to 33, we get this, and then we solve this, and we get -17 here. But again, remember, the absolute value of -17 is 17. 17 minus 9 is 8. Okay, and then likewise over here, plug in -18, and of course we get positive 17, and of course the absolute value of positive 17 is still positive 17, and of course we get 8 equals 8. And so we just showed that they are indeed solutions. Okay, so now here's another one. So we're going to do the exact same thing. So we're going to solve for the absolute value. So we're going to isolate the absolute value sign, and we're going to do that, we're going to subtract 5 from both sides, and that's going to give us an 8 on this side. And then we're going to set this equal to 8 and set it equal to positive 8. So we're going to drop the absolute value signs, and we'll have -2x equals 8 and -2x equals -8, and then we'll just divide both sides by 8. Okay? Now notice something here, right here. We could take this multiplication here. So inside we have this constant and we have x. We can split this up into the absolute value of -2 times the absolute value of x equals 8. And of course this is going to become 2. And then look what we get. We get the absolute value of x is equal to 4. And we get x is equal to -4 or x is equal to +4. And of course, if we check those, we get that they are both solutions. Okay, look at this. Now we've got 2. So how are we going to do this? It says solving absolute value equations with 2 absolute value expressions. Well, let's isolate this for a second. So we know that this means that this, if we drop the absolute value signs here, we said this is going to equal this, or it's going to equal the opposite value of this. Okay? So it says the equation has this form, absolute value of A equals absolute value of B, where A equals this and B equals this. From our previous discussion, all solutions can be found using A equals B and A equals -B. Okay? And so A equals B means that this is equal to this. Okay? Which then reduces this because we're going to subtract 7 from both sides. So we get that -8. And then we divide by 2 and we get x equals -8. And then the other one is A equals -B, which is going to give us this here, which is going to give us this, right? distribute the negative sign. This becomes negative, this becomes plus. And we solve, and we get x equals -2. So we get -8 and -2. Okay, and then we need to verify them by plugging into the original equation. Okay, but notice that by setting them equal to each other, a equals b, or setting them equal to the opposite of each other, works in all cases. So remember, just use the absolute value sign for one of these. This means that if we drop the absolute value signs, we're going to say 2x plus 7 equals the absolute value of x minus 1, or equals the opposite of the absolute value. Now, if this is positive, right, then so is this going to be positive. So we can set them equal to each other. So think about it. If this is positive, right, then this is also going to be positive, and we can set them equal to each other. That's a equals b. If this is negative, then it's going to be the opposite value of this, okay, because this is also negative. So then the absolute value of this is going to be the opposite of this, so we can set a equal to -b. So both of these will solve. So anytime you have two absolute values, you can set them equal to each other and then just do the a, which is the inside, and b is the inside here. So you go a equals b, and then a equals opposite of b. So now let's look at this one. So now we're going to deal with inequalities. Okay, so solving less than absolute value inequalities. Okay, so this is going to be key. It depends. This is going to something you're going to want to remember because it really depends on whether it's less than or greater than. Okay, so let's do these each here. So for part A, again, if we use this inequality, and again, remember, the inequality stays this way unless we multiply or divide by a negative number. So here we're going to multiply by 4. Okay, so that's not going to change anything. So we're going to get the absolute value of 3x plus 2 is less than 4. And of course, we're isolating the absolute value on one side of the inequality. And so now what we're going to do is we're going to set this up, and we're going to say, okay, we're going to say if this is less than or equal to 4, we can drop the absolute value sign and say, okay, either this is going to be less than or equal to 4, or the opposite of this is going to be less than or equal to 4. And what happens is if we divide by the negative, we have to switch the inequality. So what we get is 3x plus 2 is less than or equal to 4, and then we get 3x plus 2 is greater than or equal to -4. And if we put those together, we get this inequality. Okay, we get -4 is less than or equal to 3x plus 2, which is the same thing as saying 3x plus 2 is greater than or equal to -4 and less than or equal to 4. Okay. Let's see here. And then, of course, if we solve for the middle, so what do we do in the middle? We do have to do to both sides. We have to do everything to each piece of the inequality. So if we subtract 2 here, we got to subtract 2 from this side and subtract 2 from this side, and we get -6 and 2. And then if we divide 3 here, we have to divide by 3 here, and then we get our final answer that x is between -2 and 2/3. And so we get this interval. This is the solution interval, and we use brackets, square brackets, because of the equal sign. So this is our final solution. Okay. So what the takeaway here is that anytime you're dealing with less than or equal to with an absolute value, you're going to end up with values of x that are between two values. Okay. So now that's what we're seeing here. So if x represents an algebraic expression and k is a positive real number, and this is for less than, then the absolute value of x is less than k means or implies that x is in between -k and +k. Okay, and then we can solve for lowercase x. And of course, for this one here, we've already got isolated. So all we do is the same thing. It's going to say this is less than -5, or the opposite value of this is less than -5. And of course, if we divide by the negative or multiply by a -1, we get greater than instead of less than. Now, since the absolute value of any quantity is always positive or zero, the solution for this inequality is the empty set. Well, why is it the empty set? Because if this is an absolute value, it's always going to be positive. So we'll never have a value of this that's going to be less than -5 because this is always going to be positive. So this is a false statement. It'll never be true. So this will be the empty set. Okay, so now what about greater than? Greater than is going to be is going to have two solution sets. So let's go back to this one right here. So you could look at less than as saying, hey, x is going to be less than or equal to this value and greater than. So we're looking at an intersection. So we're saying everything that's between these two numbers. Okay, so whenever you see less than with absolute value signs, you're going to be dealing with and. So we're going to be dealing with the values between two numbers. With greater than, you could think of or, because when we have the absolute value of some algebraic expression greater than a constant, it's going to be an or. So we're going to have two intervals to put together. Okay, so I hope that makes sense. So here's an example. It says greater than, so we're going to use greater than here. In the first one here, we have less than, so what we're going to do is we're first going to divide by this -1/3. Well, when we do that, this is going to switch to a greater than. And then what we're going to do is then we can use the absolute values with the greater than. So here's the first step. So right, it switched the inequality. Why? Because we had to divide by -1/3. Okay, and so we get 6, or multiply both sides by -3. Either way, we're going to flip the inequality. And so what happens here is now we have the absolute value of 3 plus x over 2 is greater than 6. And again, what does this mean? It means that if this is positive, then 3 plus x over 2 is greater than 6. If this is negative, then we're going to say the opposite value of 3 plus x divided by 2 is greater than 6, which always leads to this. So we're going to have this is going to be less than -6 or greater than 6. Okay. So then we solve and we get x is less than -18 or x is greater than 6. Notice it's an or. Notice that x can only be this in this solution set or in this solution set, but cannot be in both. And so this is what it looks like. So the property 2 yields a disjoint interval. That's another term, disjoint intervals. So we're going to put these two intervals, these two solution sets together, solution intervals, together with a union sign. So this basically means that we're going to take all the solutions in this range, all of the solutions in this range, and we're going to put them together. So this is the union. So this is like an or. And then on the graph, this is what it looks like. All the solutions are going to be in these shaded regions. Now B, again, we're going to do the same thing, but we have a negative. So remember, absolute values of a negative cannot be negative. This will always be positive. So again, here we're saying values that are greater than or equal to this value. Okay, it says since the absolute value of any quantity is always positive or 0, the solution for this inequality is all real numbers. Why is it all real numbers? Because we're looking at values that are either greater than or equal to negative 3 halves, okay? Or we're looking for values that are uh, less than or equal to positive 3 halves. And since the absolute value of a number can never be negative, well, if it's an either or, well, they don't exist. Okay? So, hold on a second here. This is a typo. Can that be real numbers? Hold on a second. Solve this. We get 5x plus 2 is greater than or equal to negative 3 halves. So we get negative. What do we get? We get negative. So 1.5. So negative 3.5 divided by 5. Okay, so we're going to have a negative value. So we want x is greater than this value. And then if we take the opposite of it, okay, so there's going to be some overlap here. So this is going to be all real numbers. Work this out and graph it. And from what I understand, I think you're going to get overlapping arrows going in opposite directions. So it's going to be the union of both those sets, which is going to be the entire number line, which is all real numbers. So again, make sure you work this out, just like they did up here, and you'll find when you get to your two inequalities, and you graph them, you're gonna get two overlapping um, intervals, and which is going to give you all real numbers. So it'll be everything. So here we go. So special cases here. So given k is a positive real number and a represents an algebraic expression, the absolute value of a equals negative has no solutions, because why? Absolute value of any expression cannot be negative. So this has no solutions. The absolute value of a being less than a negative k has no solutions. Okay? Because again, can't be negative. So absolute value of any algebraic expression cannot be negative. Okay? If it's the absolute value. So both of these have no solutions, and that should be intuitive based on the understanding of absolute value. And then finally, the greater than, absolute value being greater than a negative value of k is true for all real numbers based on the last example that we just did. So let's do some application. Now here it says for new cars, the number of miles per gallon a car will get is heavily dependent on the weather. It is used mainly for short trips, on whether it is used for mainly short trips and city driving, or primarily on the highway for longer trips. For a certain car, the number of miles per gallon that a driver can expect varies by no more than 6.5 miles per gallon, above or below its field-tested average of 28.4 miles per gallon. What range of mileage values can a driver expect for this car? Okay, well, if we think about this, we know that it's going to vary by no more than 6.5 miles per gallon. So if we think about this, it could be no more than 6.5 milligrams above or below, which means we can add or subtract that amount from the 28.4. And that's going to give us our range, because what we can then do is take both of those values right? And we know where our range of miles per gallon is going to be. So here we go. So this is the setup. So again, draw a picture. If you have the number line, the field tested factory display. So this would be your sticker, right? You go look on the sticker on the car and it'll show the average miles per gallon, right? And from the factory tested, so in this case, 28.4. And so what we're going to do is we're going to subtract and add 6.5, and that'll give us the maximum and minimum MPG for this model car. So we let M represent the miles per gallon a driver can expect. Then the difference between M and 28.4 can be no more than 6.5. So we can write this as an absolute value. Even though we've already thought through it, we know what we're going to do, you can write this as an absolute value problem because what you're saying is that the absolute distance, the displacement from whatever the value is of M, right, is either going to be going to be no more than 6.5 miles per gallon. Okay, so you're saying, okay, whatever this value is, right? So you're in the center, and you say, okay, whatever the M is, right? Whatever the mileage is, the gas mileage is going to be. I know that if I subtract that from 28.4, or take M minus 28.4, that absolute value will be no more than 6.5. And so you can see that right here, okay, because if you solve this here, then what you're saying is that M minus 28.4 is between these two numbers, right? Can't be any more farther away than this number, okay? And so if we add 28.4 from both of these, well, what do you get? Well, you get 28.4 plus 6.5, and you get 28.4 minus 6.5. And so then you get your two ranges. So your miles per gallon can be no lower than 21.9 miles per gallon and no higher than 34.9 miles per gallon. And so that's the range. Okay, and that ends this video. And next time we're going to consider complex numbers, and we're going to go through these objectives, and we're going to show you what is a complex number, how do you use it, how do you use operations for it. Once you do these and you practice with these are very easy, but we'll do that next time. So until then, have a great day. Make sure you put in the time and watch the videos and practice. Okay, take care.